Okay, everyone. Assalamu alaikum. Let's begin then. So this is the last topic that we have in our syllabus. We're done with everything else in paper 3. Iteration. Now, in the syllabus, it says numerical methods of solutions. So basically, there are a number of different methods that we have for solving equations that we categorize as numerical methods. In our syllabus, we have one particular method out of them, and that's called iteration. Okay, so that's why we sometimes call this topic iteration, because that's the only method that we have in our syllabus, or we also call it numerical methods of solutions. Now, what is this about? What are numerical methods of solution? Let's understand this. Okay, so in our syllabus, both in paper 3 and in paper 1, we have learned how to solve a number of different types of equations. So for example, in paper 1, you start with quadratics, you start with coordinate geometry. So you know how to solve straight line equations, you know how to solve quadratic equations. In paper 3, you also cover polynomials, so that in polynomials, we learned how to solve cubic equations, sometimes quartic equations, power 4 equations. We now know how to solve those types of equations. Then we've also solved equations involving modulus, right? Equations like these. We've learned how to solve equations that involve logs, for instance, equations that look like this. When we have exponential equations, e raised to power something, we've also learned how to solve them. Then in trigonometry, we learn how to solve equations involving trigonometric functions. For example, if we have an equation like this, we know how to solve this as well. So across paper 1 and paper 3, what we've done is we have learned different methods for solving different types of equations. But still, there are a lot of other types of equations that we do not know how to solve, which basically are going to be some combinations of the different functions that we have done. So for example, we know how to solve a quadratic equation, but if we have a quadratic equation in which we have maybe logs involved as well, so something like this maybe, so not exactly a quadratic equation, but power 2 equation. So if we have something like this, ln of 2x plus 1, let's say that is equal to 5x cubed plus 2x minus 3. So it's a cubic function on one side, and on the other side, we have log function. How would you solve something like this? We can't do it using polynomials. We can't do it using any of the log rules as well. And then you might have an equation that looks like this. For instance, you have a quadratic, you have a trigonometric function on one side, maybe tan of 2x, and then on the other side, let's say you have something exponential, e raised to power 5x minus 2. Now, what if you have an equation that looks something like this, or any other random equation that you do not know how to solve? How would you approach equations like these? How would you solve these equations? That's the question. We don't have any algebraic methods, at least in our syllabus, that we can use to solve any of these equations, right? For equations like these, for which we do not have any algebraic methods, we have another category of methods that we call numerical methods. And using numerical methods, what we can do is we can estimate the solutions of these equations somehow. Let's suppose we had this equation, tan of 2x equals e raised to power 5x minus 2. And we don't have any additional information apart from this. We want to solve this equation. Can we try estimating a solution for this equation somehow? One idea could be that we could try guessing some values. right? Try inputting some random values of x and see if any of them works. And if we get something that looks like it's going to be close to the answer, we try more values close to that. But that's very unreliable. If just inputting random values, it's very unlikely that you would get to the correct result. But is there another way that we can use to estimate solutions of an equation? Remember something that you've done in O-levels, graphs of functions, graphical solutions of equations. That's an idea that we could use here. For instance, if you have an equation like this, you can say you have one function on the left side, which is y equals tan of 2x. And you have another function on the right side, which is y equals e raised to the power 5x minus 2. If you could sketch the graphs of these functions, then the points of intersection, if there are any, of these two graphs, they can give you the solutions of this particular equation, right? So that's one method using which you can estimate the solution of this equation, that you sketch the graph of this function, you sketch the graph of this function, and you see wherever they are intersecting, you can say that they are the solutions of this particular equation. But using graphs, you can never get an exact answers, right? You can only get estimates of the solutions. So that is why we need something that we can use to increase the accuracy of the answers that we might get from a graph, okay? And that is where these numerical methods are going to come in, using which we can increase the accuracy level of the answers that we get, okay? Now, how do we go about doing all of this? We will try to understand this process using some simpler example, first of all. Now, the first 15-20 minutes today, they are going to be a bit abstract. Initially, you might not understand fully how all of this makes sense eventually and how all of this is going to be used to solve any questions later on. But I would say just be patient for the next 15-20 minutes. Try to understand what you're doing. And then eventually, after 10-15 minutes, all of it is going to start making sense. Okay? Just make sure that you're focusing right now. I'll take questions later on as well. If you have any, if you have something to ask in the middle, you can always post in the chat. But focus more on listening right now and try to understand what I'm trying to explain. And then after 15 minutes, it'll all start making sense. Let's start with a simple equation. Let's say we have an equation like this: x cubed minus x plus 3 equal to 0. We have this equation. Now, this is a cubic equation, right? Do we have any method for solving cubic equations? We have done polynomials. In polynomials, we learned how to solve cubic equations. But for that, we needed one factor given, right? So we needed one factor given using which we could find the other factor by long division, right? So if we had one factor of this polynomial given, we would divide this by that factor and we would get the other factor in the quotient, and then we could factorize that and then solve that further. But what if we do not have any factor given and we just have this cubic equation and we want to solve this? Now, one idea can be, as we discussed above, we say this is one function y equals x cubed minus x plus 3, and this is another function y equal to 0. We have these two functions, okay? And we sketch these two functions now. How can we do that? Y equal to 0, that is x-axis, right? Y equal to 0 is the line that represents the x-axis. So I can say this is the y equals 0 line. And then x cubed minus x plus 3. This graph might look something like this. X cubed minus x plus 3. Let me actually just quickly see how the graph might look like using a trick here. Just give me a second. What I do is I will, since we're just trying to understand how the process works, I'll do it in this mask quickly. so that we are accurate about it. So the function was x cubed minus x plus 3. X cubed minus x plus 3. Okay, so the graph of this function looks like this. Okay, this is the graph of the function. Okay, now we have a cubic function and we have a straight line y equal to 0. They are intersecting at one particular point, and that is this point here. That's the solution of this equation. Now, this graph represents y equals x cubed minus x plus 3. This is the function on the left side, and y equal to 0 is the straight line. The point of intersection of these two functions is going to be the solution of this equation. Now, when you sketch a graph like this, if you're just sketching, all you would know would be an estimated position of this point. On this graph, you can see that this point is somewhere between -2 and 1. So you have -2 on the left side here, and you have -1 on the right side here. That is all that you know from the graph, right? That the solution lies somewhere between -2 and -1. Okay, the solution lies somewhere between -2 and -1. Now, since you're just sketching and it's not a very accurate sketch, you can't find the solution to, for example, 2 decimal places, 3 decimal places. It's hard to just look at the graph and say, this is the solution to 2 decimals or 3 decimals, right? This is where numerical methods come in. And what we can do is we can use an idea like this. We can say, okay, the solution lies somewhere between -2 and -1. This is the point where the solution lies. At the point of intersection, what's the y value? The y value is supposed to be 0. On the right side of the point of intersection, the curve has a positive y value. On the left side of the point of intersection, the curve has a negative y value. So if you have that function, which is x cubed minus x plus 3, let's call this function f of x. If I were to input x equal to -2 in this, what value of x would I get from this? -2 whole cube minus into -2 plus 3. What's the value that we get from this? -8 plus 4 plus 3, that is -1. This is a negative value. And then if I input -1 in this, what does that give me? -1, if I input that, -1 minus -1 plus 3, this results in 3, which is a positive number. So at -2, the function has a negative value. At -1, the function has a positive value. 0 is going to come somewhere in the middle, right? It's -3, the other one. Oh yeah, it's -3. Sorry about that. This is -3. This is -3 and this is positive. This is +3. So one of them is negative and the other is positive. At the point of intersection, this value is supposed to be exactly equal to 0. How do we get closer to this actual answer? How do we get closer to this actual answer? For this, you can use this idea. Draw a number line to try to understand this better. You have -2 and you have -1. At -2, you are getting a negative value for the function. Okay. At -1, you're getting a positive value of the function. The actual solution is going to lie somewhere between -2 and -1, right? Because when you go from negative to positive, 0 is going to come somewhere in the middle. If you want to increase the accuracy of your answer now, one idea could be that you say, okay, let's try another value in the middle. So now the graph is only telling you that the point that the solution is somewhere between -2 and -1. Now that you've got to that point that the solution is somewhere between -2 and -1, now you can try to narrow down on the solution. And how can you do that? You can say, let's take the middle point, the midpoint of -2 and -1. What's that? That's -1.5. And see what value of y this function gives when you input x equal to -1.5 in this. So try doing that. Find f of -1.5 and see what that turns out to be. Let me do that for you in front. On this calculator. So we have -1.5 whole cube minus -1.5 plus 3. This is giving me a positive value, which is 1.125. Okay, this is a positive value, 1.125. Now, all that matters is if this value is positive or negative. This value is turning out to be positive, so we have a positive value here. Now, think about it. At the point of intersection, the y value is supposed to be 0, exactly 0. Where is 0 going to be? Is it going to be between positive and positive? No, 0 comes between a negative value and a positive value. So earlier we knew that the solution is somewhere between -2 and -1, but now that we know at -2 we have a negative y value, at -1.5 we have a positive y value. That means the solution is actually going to be between -2 and -1.5. So we have narrowed down the interval that we have. We started from -2 and -1, and now we are saying that it's actually going to be somewhere between -2 and -1.5. Now we can keep repeating this process. Try a value in the middle. So try a value in the middle like this. This is -1.75, right? Let's halve this interval down further and see what value you get when x is equal to -1.75. Let's input that here. -1.75 whole cube minus -1.75 plus 3. What's the value that I'm getting? This is a negative value. That tells me at -1.75, the y value is negative. Okay. Now, this is a negative value. What does that mean? Now we have narrowed down the range even further, that now it's between -1.75 and -1.5. The actual solution is going to be somewhere between these two values, between -1.75 and -1.5. Now we can narrow down the interval even further. Try a value in between these two values. You can try, for instance, -1.65. It doesn't have to be exactly in the middle, but try another value. Let's say -1.65. Let's see what this turns out to be. Okay, this is positive. So -1.65, where is that going to be? This is -1.65. At this point, I'm getting a positive value. Okay, what does that tell me now? The solution is between -1.75 and -1.65. So I've narrowed down the interval even further. I can try -1.7, right? A value that's between -1.75 and -1.65. Try another value. Let's say -1.7. Let's see what we get for that. At -1.7, I'm getting a negative value. So somewhere around here, we might have -1.7. This is -1.7. At -1.7, I'm again getting a negative value. What does that tell me? Where is the sign changing? It's going from negative to positive between -1.7 and -1.65. So I've narrowed down the range so much that I can now say that the solution is somewhere between -1.7 and -1.65. If you have any value between -1.7 and -1.65, if you round that off to, let's say, 1 decimal place, what would that be? That would be -1.7. So we have got a solution correct to 1 decimal place. And we can keep repeating this process to improve this accuracy level further and further Right now, yes, we have gotten a value that's correct to 1 decimal place, but we could keep increasing this level of accuracy to get to the answer to, let's say, 2 decimal places, 3 decimal places, 4 decimal places. If I were to show you the actual answer for this, the actual answer is minus 1.67. And you see, we got minus 1.7. That's very close to this actual answer. And we could just keep repeating this idea to get closer and closer to the actual answer. This method that we have used here, where we started from an estimate that the solution is going to be somewhere between -2 and -1, and then we repeated this process of narrowing down the interval that we had to get closer and closer to the actual answer. This is called a numerical method, right? Using methods like these, what we can do is we can estimate the solutions of any equation, right? This is a cubic equation, but we could do this for any equation that we can find. So even if you don't have an algebraic method for that, you can use something like this. Just sketch that. You will get a point of intersection. You at least get an estimate from that, okay, this is where the solution is roughly going to be. And then you try some values and see where the sign is changing from negative to positive or positive to negative. And that gives you the solution like this. Okay. This is the idea of numerical methods. All right. Now, all of this was just to give you an intuition of how this process works. Okay. This is how numerical methods work. Now, what exactly would you have to do? What exactly would you have to do in your exam? There are 2, 3 different types of questions that you see on iteration. Number one is they will ask you to show that the solution of an equation lies between 2 given values. Let me show you an example of that. So one thing that you would have to do would be, they would say, prove by calculation that a solution to the equation x cubed minus x plus 3 equal to 0. This equation, it lies between -2 and -1. So they'll ask you to do something like this, that they will ask you to prove that the solution of an equation lies between 2 given values. That's one thing that you would have to do. Now, how do you approach problems like these? You have x cubed minus x plus 3 equal to 0. What you do is you say, this is a function which has to be equal to 0, and that is going to give you the solution to this equation, right? The 2 values that you have given there, -2 and -1, you input those values one by one in this function. So you input f of -2, input x equal to -2. This would give you a value which is -3. And then you input f of input x equal to -1, and that would give you a value which is +3. One value is negative, the other value is positive. Think about the graph of this function. Even if you don't know the exact shape, you can say it would be something like this, that you have x-axis here. At one point, the y value is negative. So when x is equal to -2, the y value is negative. That means the graph is going to have a point that is below the x-axis. At the other point, x equal to -1, let's say this is x equals -1, the function has a positive value. So that point is going to be above the x-axis. That might be here. Now, when you go from the point on the left side to this point on the right side, what will happen? You will always pass through the x-axis. So if you have to go from this point to that point, no matter what the shape of the graph is, it might be like this, it might be like this, it might be like this. No matter what the shape is, you are going to cross the x-axis in that process. You're going to cross the x-axis in that process. Why? Because one of them had a negative y value. This is a negative y value. And the other has a positive y value. If you're going from a negative y value to a positive y value, 0 is going to be somewhere in the middle. That means you are going to cross the x-axis. And that proves that a solution to this equation, it lies between -2 and -1. Why? We would say something like this. We would say, since f of -2 and f of -1, they have different values, they have different signs. One of them is positive and the other is negative. That means a solution lies between these two values. A solution lies between x equals -2 and x equals -1. So this is one type of question that you would have to do, that you would have to prove that the solution to an equation lies between two given values. You would input those values in the function. In this case, you have to prove that the solution lies between -2 and -1. What you do is you input x equal to -2, then you input x equal to -1. One of them is going to give you a positive value, the other is going to give you a negative value. If the sign is changing, that means that there is a solution between these two values. The graph is going to cross the x-axis between these two values. Okay. This is one thing that we have to do. It's a standard question that you will see in this topic. You have to prove by calculation that a solution of an equation lies between two given values. Okay. Now, this is one example of that. Let's take another example in which it's not as straightforward as this. So let's say you have to prove that the solution of an equation lies between some other two values. Let's say you have another equation now. Instead of x cubed minus x plus 3, what if you have an equation that looks like this? X raised to the power 5 plus 3 equals 5x plus 2. We have to prove that the solution to this equation lies between x equals 1 and x equals 2. Now, this is an equation in which we have power 5. Do we know how to solve equations like these? No, we don't have a direct method for solving equations like these. But can we at least prove that that one solution of this equation is going to be between x equals 1 and x equals 2? Now, how can we do that? We do something similar to what we did in the previous case. We input x equals 1 in this and x equals 2 in this. If the sign is changing, we can say that a solution lies between these two values. But there's a catch here. In the previous example, on the right side, we had 0. Since we had 0 on the right side, we were comparing, we were basically looking at the graph and seeing where does the graph cut the x-axis. If one value was positive and the other was negative, then 0 would be somewhere in the middle, right? But in this example, you don't have 0 on the other side. If you have an equation like this and you have to prove that the solution of this equation lies between two given values, first of all, you have to convert it to a form like that you have every term on one side. So this can be written as x power 5 minus 5x. Bring 2 to the left side as well. And that will give you plus 1 on the left side equal to 0. The first thing that you always need to do in such problems is bring everything in the equation to one side and leave only 0 on the other side. So you have x power 5 minus 5x plus 1 equal to 0. Now you do this exact same process that you did in the previous part. You can say this is the function that we're talking about. This is supposed to be equal to 0 at some point. Okay. You have to prove that a solution lies between 1 and 2. What you do is you input x equal to 1 in this function on the left side. What does that give you? 1 raised to the power 5 minus 5 into 1 plus 1. 2 minus 5, that's minus 3. That's a negative number. Then you input x equal to 2 in this, and that gives you 2 raised to the power 5 minus 5 raised to 5 into 2 plus 1. What's this number? 2 raised to the power 5 is 32. 33 minus 10, that's 23, right? This is a positive number. One value that we're getting is negative, the other value that we're getting is positive. What does that mean? We have 0 on the other side, right? That means we're talking about intersection with the x-axis at x equal to 1. We are getting a negative value. At x equal to 2, we are getting a positive value. If the graph has to go from this negative value to that positive value, there has to be some intersection with the x-axis in the middle. Okay? That means there is going to be a solution between these two given values. So we say f of 1 and f of 2, they have different signs. They have different signs. The statement is important. Since they have different signs, a solution lies between x equals 1 and x equals 2. Okay? This is one thing that you would have to do, that you would have to prove that a solution exists between two given values. Now, this is one way to do it. When they ask you to prove by calculation that a solution lies between these two values, this is how you do it. The other idea is they would ask you to sketch a graph, and using that sketch, prove that a solution lies between two given values. In that case, you would just sketch it, and on your diagram, you would see that the point of intersection is between 1 and 2, and that will prove that there is a solution between those two given values. Now, once you have a solution between those two given values, the next question is, how do we get to that actual solution? Okay. One idea for that is what I showed you earlier, that we start from these two given values. Let's say in this case, we have 1 and 2. At 1, we will, at 1, we have a value that is negative. At 2, we have a value that is positive. You try inputting more values in the middle. For example, you could try what happens at x equals 1.5. And then if that's negative and positive, negative or positive, depending on that, you take another value and another value, and you can keep closing closing in on the actual solution, and that will get you closer and closer to the actual answer. This is one idea that you can use. Okay. But what they will ask you to do instead of this is to use a method that's called iteration. Okay. This earlier idea that I showed you, where we input values like this is a numerical method. It's like a binary search method, which some of you who are doing computer science might be familiar with that. So we're trying values in the middle, and then again another value in the middle of the new points that we get, and keep repeating this process. It's like a binary search algorithm. This was just to show you, give you an intuition of how this process works. You will not be required to use this method in the exam, but this is one possible numerical method that you could use. The method that is part of your syllabus is called iteration. So you would be asked to solve equations using something that we call an iterative formula. Iterative formula. The equation that we saw on the previous page, one equation that was x power 5 plus 3 equals 5x plus 2. X power 5 plus 3 equals 5x plus 2. This was an equation that we had. When we rearranged this, we got x power 5 minus 5x plus 1 equal to 0. We wanted to solve this equation. Now, what we have done is, we have already proved that a solution to this equation lies between 1 and 2. That's something that we have proved. Okay, we have proved that a solution exists between x equals 1 and x equals 2. That is something that we have proved already. Okay. Now, this is something that we know until now. How do we get the actual solution? How do we get the actual solution? For which, for this, we can use something that we call an iterative formula. Now, this equation can have one possible iterative formula that looks like this. xn plus 1 equals 5xn minus 1 whole raised to the power 1 over 5. Now, how do we get to this iterative formula? We'll talk about that in a few minutes. But for now, let's assume you are given this iterative formula. So mostly they give you the iterative formula in the question itself. Sometimes you have to figure it out yourself as well. We'll talk about that in a few minutes. But for now, let's assume this is the formula that's given in the formula given in the question. They give you this equation and they tell you that you can use this iterative formula to find the solution of this equation. Okay. So for now, let's assume it's given in the question. Now, how do you use this iterative formula to find the actual solution? You need a starting point for this. Okay. This formula requires a starting point. Your best guess about the actual solution. Until now, you only know that the solution is going to be somewhere between x equals 1 and x equals 2. It could be anywhere between those two values, right? Between x equals 1 and x equals 2, it could be any value. What would be your best guess about the solution? In the absence of any additional information, you can say, okay, it's somewhere between 1 and 2, then what about the midpoint, maybe 1.5? Now, it does not necessarily, it's not necessary that you always start from the midpoint. But that's a convention that we have, that that if we know that the solution is somewhere between x equals 1 and x equals 2, then if we don't have any other additional information, we say our best guess about the solution is that it is the midpoint of these two numbers, which is 1.5. And we use that as the starting point for this iterative formula. We write it like this, x1 equals 1.5. That's the starting point that we have. In iteration, we will always need to have some starting point, right? There has to be some value that we start from. Okay. In this case, we said our best guess about the actual solution is 1.5. So we start with 1.5. Now, using this starting value, what we will do is we have x1 right now, right? We want to find x2, x3, x4, x5, and so on. Now, how do you find all of them using this iterative formula? Let's understand the notation that we have here. This is xn plus 1, and this is xn on the right side. If I want x2 equal to something, what value of n would I have to input here so that at the bottom here, I get x2, right? In place of n plus 1, I need 2 there. What value of n would I have to input there? N equal to 1, right? If I input n equal to 1, the formula becomes something like this. x2 equals 5x1 minus 1 whole raised to the power 1 over 5. Using this formula, what you can do now is you can figure out the value of x2. Let's see what that turns out to be. 5 into 1.5 minus 1 whole raised to the power 1 over 5. Let's evaluate this and see what this turns out to be. 5 into 1.5 minus 1 whole raised to the power 1 divided by 5. Okay, so I'm just inputting this value on my calculator, and that's giving me some number. Let's write that down here, 1.454. Let's say we want to write this to 3 decimal places. Let's leave it like this, 1.454. That's the value of x2 that I'm getting. Okay, 1.454. Or let's actually use more decimal places. Let's say 5 decimals. So mostly you have to use more decimals in iterations like this. Let's say we write 5 decimals. To 5 decimal places, we have this number. This is x2. Okay, now once we have x2, how can we find x3 after that? Let's look at the formula again. What value of n would I have to input here to get x3? I would have to input n equal to 2 there. When I input n equals 2 there, the formula becomes x3 equals 5x2 minus 1 whole raised to the power 1 over 5. Now we already have the value of x2, that's this. I can input that here. 5 into 1.45406 minus 1 whole raised to the power 1 over 5. Let's see what that turns out to be. 5 times the previous answer, minus 1, whole raised to the power 1 over 5. Okay, that will give me some value for x3. That's 1.44364 to 5 decimal places. That's the next value that I'm getting. Okay. Now I can evaluate x4. How would that be evaluated? I input n equal to 3. What is x4 going to be? If I input n equal to 3 in this formula, that gives me x4 equal to 5x3 minus 1 whole raised to the power 1 over 5. And now I input that previous value here in the formula, and that becomes 5 into 1.44364 minus 1 whole raised to the power 1 over 5, and that will give us some answer. This is going to be 1.44123. And you keep going on like this. You find x5, x6, x7, x8. Eventually what will happen would be these numbers would stop changing, right? They will become fairly stable. When they become stable, you say that is the final solution of that equation. All right. When these values become stable, you see they're not changing as much. And if you keep going on like this, eventually they will become very stable, and you can see that that is the solution that you're looking for. Now, in this case, I evaluated all of these numbers manually like this, that I find one value, then I input that value in the calculator again, I found another value, and then I input that value in the calculator again to find the next value. There's a trick that we can use to do all of this calculation much quicker, and that is what you would be doing in the exam. Let's learn that process. If you have an iterative formula that looks like this, xn plus 1 equals 5xn minus 1 whole raised to power 1 over 5. That's the iterative formula that we're given there, right? Xn plus 1, that's 5xn minus 1 whole raised to power 1 over 5. That's the formula. We are given that x1 equals 1.5. That's the starting point that we have. X1 is 1.5. Now, you do not have to show all of this. That was just to explain to you how this process actually works behind the scenes. But what you can do is you can do these calculations directly on your calculator and just write down the final answers. Now, how would that work? This is the process that you would follow on your calculator to do this directly. The starting point is 1.5. The starting point is 1.5. What you would do would be, you would input 1.5 in your calculator first of all. Input 1.5 in your calculator. That's the starting point. Input 1.5 and press the equal to button. That's what you do. Let me write that down here. Input 1.5 in your calculator, and then you press the equal button. Okay. Now, what happens when you do that? The calculator saves this number in the answer button of your calculator, right? Now, the answer button that you have here, if I were to evaluate that, that's 1.5. So this number is saved in the answer button on my calculator. And now on my calculator, what I can do is, I can just input this formula in such a way that wherever I have xn, I would replace that with answer. So it becomes 5 into answer minus 1 whole raised to the power 1 over 5. That is what I'm now going to input on my calculator. Remember, the answer button has 1.5 saved at this point. If I input this thing on my calculator now, 5 into answer minus 1 whole raised to the power 1 over 5, that is going to give me the value of x2. And you can write this value x2 directly here. The question is normally going to give you the level of accuracy that you want in these iterations. Let's say they want you to write down each iteration to 5 decimal places. Normally, they will give you this instruction in the question. Let me write that down here. Let's say they're saying, write each iteration to 5 decimal places, and then final answer to 3 decimal places. Let's say that's the instruction that we have in the exam for this question. Now, when we write that here, we would say this is 1.45406, right? To 5 decimal places, this is the value. This is the value that we are getting. And now the good part about this method is, now the answer button in your calculator, instead of 1.5, it has this number stored, right? Now it has this number stored, 1.454006. You don't have to do anything additional on your calculator now. You just press the equal to button again now. Just press the equal to button again. Because now the calculator has 1.454 saved in the answer button. It will input that in place of answer and give you the next value. So all you have to do is just press the equal to button. And that gives you the next value, which is 1.4436. Then you have 36. If you round that off to 5 decimal places, that will be 364. That's the next value that we're getting. And then you just press the equal to button again. And that gives the next value. This is 1.441227. That becomes 23 to 5 decimal places. Press the equal to button again. X5 turns out to be 1.440669. If you were to round that off, that becomes 067 to 5 decimal places. Press the equal to button again and see what that gives you. 1.44054. Press the equal to button again. The next value that I'm getting is 1.44051, and so on. You see, the values are not changing by that much anymore. Right? 44054, 44051. You want your final answer correct to 3 decimal places. To 3 decimal places, it was 1.441 here. It was 1.441 here. It's 1.441 here. It's 1.441 here. So for a number of consecutive iterations, it is stable to 3 decimal places. You can stop at this point and you can say that the final answer is supposed to be 1.441. Or you can keep going on for a couple of more iterations if you want, just to be sure, because at some point, all of these decimals are going to become equal. If I were to do it one more time, that gives me 1.44050. Let's do it one more time. That again gives me 1.44050. So you see, all the decimals have become stable now. You want the final answer to be correct to 3 decimal places. Based on this, you would say the value of x, that's the solution of that equation, is 1.44050. You can say that becomes 441. That's the solution that you have for this equation, 1.441 to 3 decimal places. This is how we use an iterative formula. Okay. So given an iterative formula, how can we find solution to an equation? We would have some starting point that will be given in the question, or you will have some way to figure that out. For example, if we have already proved that the solution lies between x equals 1 and 2, then you take the midpoint of them and you say the starting point, your best guess about the actual solution is 1.5. You treat that as the starting point, 1.5, and then you just keep repeating that process until it becomes stable like this. All right. This is how we use the iterative formula. Now, the next question is, where does this iterative formula come from? How do we know this is the iterative formula? Yes, mostly they will give you the iterative formula in the question, but sometimes you'll have to figure it out yourself as well. Now, how can you figure out the iterative formula yourself from a question? So what if they ask you to derive an iterative formula? How will that work? Deriving an iterative formula. So we have this equation, x raised to power 5 minus 5x plus 1 equal to 0, right? That was the equation that we had there. X raised to power 5 minus 5x plus 1 equal to 0. This was the equation. If you want to figure out yourself an iterative formula from this, how do you do that? The idea is you make one of these x terms the subject. You make one of these x terms the subject of your equation. Now, how does that work? There are two possibilities. You can either make this x term the subject. Subject means you take keep this one x term on one side and all the other terms on the other side. Let me explain what I mean by that. Let's start with this x first. Let's say I want to make this x the subject. So keep this x on one side and take everything else to the other side. What would happen if I try to do that? I would get x raised to power 5 equals 5x minus 1. Now the x that I have on the left side, I want the power of this x to be 1. Okay. How can I do that? This is x power 5 right now. If I want to make this x power 1, I can take power 1 over 5 on both sides, and that would give me x equal to 5x minus 1 whole raised to power 1 over 5. All right. And now once I have a form like this, all I have to do is, with the x on the left side, put n plus 1, and with the x on the right side, even if they're multiple, so you might have multiple x terms on the right side as well, with all of them, you put n, and that's your iterative formula. Xn plus 1 equals 5x minus 1 whole raised to power 1 over 5. And that's exactly what we were given in this question here as well. Xn plus 1 equals this, 5xn minus 1 whole raised to power 1 over 5. And that's what we got here, 5xn minus 1 whole raised to power 1 over 5. You can derive this iterative formula yourself like this. All right. This is one idea if we make this x the subject. But what if we were to make this x the subject? That's also possible. Let's see what happens if we were to do that. If I make this x the subject, in that case, I would get something like this, minus 5x. So I'm keeping this term on one side, taking everything else to the other side, so that it becomes minus x power 5 minus 1. I can multiply the whole equation with negative to get rid of the negative sign. 5x equals x power 5 plus 1. Now divide 5 on the other side. That gives me x equals x raised to power 5 plus 1 divided by 5. So if I make this x the subject, I get something like this from this. All right. And all you have to do now is, on the left side, put n plus 1 with x. On the right side, put n with x. And that is what your iterative formula is going to be. Okay, that's what your iterative formula is going to be. Now, you could either have this iterative formula or have this iterative formula. If an equation has multiple solutions, generally what happens is one iterative formula might give you one solution and the other iterative formula might give you another solution, right? That's what generally happens. But if you have to derive it yourself in a question, you will have some hint in the question that basically makes it clear for you whether you have to use this formula or this formula. So if they want you to derive the formula yourself, it will be very clear in the question if they want you to have this formula or this formula, right? But that's the process. You make any one of the x terms the subject in that equation. Once it is made the subject, on the left side, you put n plus 1 with x. On the right side, with all the x terms, you put n, and that gives you the iterative formula. All right, that's the way to derive an iterative formula. Now, sometimes what happens is you have an iterative formula given, and you have to figure out which equation this iterative formula belongs to. For instance, if you were given this iterative formula, let's suppose you were given this iterative formula is given, and you have to find the original equation. Finding original equation from an iterative formula. So going backwards, finding the original equation from an iterative formula. How would this work? Let's say I have this iterative formula, xn plus 1, this equals xn raised to power 5 plus 1 whole divided by 5. This is an iterative formula that I have. What I want to do now is I want to go back to the equation that this iterative formula comes from. All right. How do I do that? I can just remove n plus 1 and n from this. Just get rid of n plus 1 and n, because that's what we introduced when we were forming this equation, forming this iterative formula, right? We put n plus 1, and then when we want to go back to the original equation, we can just remove n plus 1 and n. And that leaves us with x equal to x raised to power 5 plus 1 divided by 5. Now just simplify this. Multiply 5 on the other side, that gives us 5x. On the right side, we have x raised to power 5 plus 1. So the equation becomes x raised to power 5 minus 5x plus 1 equal to 0. And that's the original equation that we had. So if you have an equation given, you know how to find the iterative formula from that now. And if you have an iterative formula given, you can go back to the original equation by just getting rid of n plus 1 and n from there. Okay? And that way you can get back to the original equation. In terms of the concepts that you have in iteration, this is pretty much all that you need to know. Let me go through these concepts again. One thing that you have to do is you have to be able to prove by calculation that the solution to an equation lies between two given values. That's one thing that you need to be able to do. In order to do something like this, you first of all need to convert the given equation to a form like this, where you have all the terms on one side and only 0 on the other side. If it's already that form, that's okay. If it's not that form, like in this question, you have to first convert it to this form, right? All terms on one side, only 0 on the other side. Once you have done that, you input those given values of x in this function. If one of them is negative and the other is positive, that proves that a solution lies between these two values. You have to write it down clearly. The reasoning for this, why you are saying that a solution lies between these two values, you would say one is negative, the other is positive. Since the sign is changing, that means a solution lies between these given values, because between negative and positive, you would have 0 somewhere, right? So having different signs or signs changing, you have to clearly write this. That's the reason a solution lies between these values. Then you need to be able to use an iterative formula. So if you have an iterative formula given, you should be able to use that iterative formula to find the solutions from that, like we did in this example. And then sometimes you would have to derive an iterative formula yourself from an equation, or go back to the original equation given an iterative formula. As far as iteration is concerned, these are all the concepts that you need to know of. Okay. But a lot of times the questions on iteration, they are a bit tricky. And the reason for that is they often come with other topics like integration. So the first part of the question might have something related to integration. It might be differentiation. A lot of times you have circular measure in the first part. That's the part that's the part that's generally more complicated. But then the iteration part is going to be relatively simpler. The only complication that you get sometimes is that the question statement is sometimes a bit confusing. Okay, the question statement is sometimes a bit confusing, and we will look at that when we look at some questions, how to basically understand the different types of statements that they give you when we do practice questions. Apart from this, the other thing that you would have to do is you would have to sketch a lot of graphs. So remember, in paper one, you've done some graphs already, like quadratic graphs, linear graphs, uh, graphs of trigonometric functions, sine, cos, tan. All of those graphs, along with some others in paper three, for example, a cubic graph, cosecant, secant, cot graphs, log graph, ln x, and e power x graph, all of these graphs, they are tested in iteration as well. So in the first part, they might ask you to sketch some graph, and using that, figure out where the solution is going to be, between what two values the solution is going to be, or maybe to find the number of solutions of an equation, you would have to sketch graphs. Okay. Now, how do we sketch the different types of graphs? We will talk about that in the next class. For now, in the remaining time, I want to do a couple of questions from the worksheet that do not involve graphs. And then tomorrow, we will be doing questions involving graphs as well, along with the other questions that we have. But when you practice, keep in mind that you need to be able to sketch linear functions. You need to be able to sketch quadratic functions, and then cubic functions. We'll talk about cubic functions in the next class, the different shapes that they have. And then reciprocal functions. Reciprocal functions are where you have x in the denominator. And then you would have sine, cos, and tan functions. You've done these in paper one, sine, cos, tan functions. But then apart from these, you have 5 other functions that you have not done before that we will be doing tomorrow. Cosecant, cot, secant. We need to be able to sketch their graphs, and also ln of something and e power something. These 5 functions, you need to be able to sketch these functions as well. We'll talk about this in the next class. For now, let's do some practice on the concepts that we have already learned. Let's try a couple of questions on this quickly. Ibrahim, I'm sorry, I don't understand your question. They will give exact same answers. What do you mean by that? Is the worksheet uploaded, by the way? Is the worksheet for iteration uploaded? Okay, good. Let's have a look at a couple of questions in this quickly to understand how this is tested. Okay, I'll start with a very simple one first. This is question number 25, first of all. Question 25 from the worksheet. They're saying the sequence of values given by this iterative formula with initial value 3.5. So they've given you an initial value. Initial value is 3.5. Now, sometimes they will give you this initial value. Sometimes you would have to figure it out yourself, given some information in the question. Like in the example that we did, we knew that the solution lies between 1 and 2. So we just input the midpoint of them, right? In this case, they've given us a starting point. We have to use this formula to calculate alpha correct to 4 decimal places, showing the result of each iteration to 6 decimal places. Now, how do we do this? We use that starting point. We say x1 is equal to 3.5. x1 is equal to 3.5. Using this starting point, you can find x2, x3, x4, and so on. On your calculator, you would do something like this. Input 3.5, press the equal to button, and then you input that formula like this. You would say answer. So in place of xn, you put answer. Answer into answer cube plus 100 divided by 2 into answer cube plus 25. You would just input this whole thing on your calculator like this. And then just keep pressing the equal to button after that. Let's do that. 3.5, we input that in our calculator. This saves 3.5 in the answer button on our calculator. And now input this formula, replacing xn with answer. Okay. So this becomes answer times answer cube plus 100 divided by 2 into answer cube plus 25. Okay, so this is the first value that we're getting. They want us to show the result of each iteration to 6 decimal places. Now, it's going to be one of the easiest questions in the exam. This part specifically, where you have to use an iterative formula to find a solution. It'll be at least 3 marks, sometimes 4 marks. These are free marks in paper 3. Easiest marks in paper 3. Apart from the modulus inequality question, that's also fairly easy. It's also easy 3-4 marks. However, since it's so straightforward, they deduct marks for every small mistake that you do. They have specified that they want an accuracy level of 6 decimal places. It has to be exactly 6 decimal places, and the 6th decimal place should be properly rounded off. Even if one number is not correctly rounded off, you will lose 1 mark because of that. Okay, so you have to be very careful about the accuracy in this question. So this result x2 is 3.68370. Now look at the last decimal place now. You have 1 6 after that. You would round it off to 2. If you write 1 there, you lose 1 mark. Okay, so it has to be exactly like this to 6 decimal places. Let's press the equal to button again. Now that gives me 3.68403, and then you have 1499. That's 1. That's x3. Let's find x4. Press the equal to button again. Okay, now that's not changing anymore. The next iteration is the same, 3.684.031. When everything becomes stable, all the decimal places become stable. When you have 2 consecutive iterations like this, you can stop at that point. You have to write down your final answer to 4 decimal places. What's the final answer going to be now? 3.6840. That is what the final answer is going to be. But now we have another problem here. They want us to calculate the value of alpha. The question says, this iterative formula, it converges to alpha. Converge means that the values become stable somewhere, right? So these values are converging to this value. What value are they converging to? They're converging to alpha, and they want us to calculate alpha correct to 4 decimal places. Now, when we write down our final answer, if we write x equal to this, we lose 1 mark. If we just write 3.6840, again, we lose 1 mark. They want us to calculate the value of alpha. For some reason, they want you to write it like this. Alpha equals this. If you don't use alpha there, you can lose 1 mark because of that. In some questions like this, they have specifically written that in the marking scheme, that if you don't say alpha equal to that value and you say x equal to that, or don't use alpha at all, you lose 1 mark because of that. Okay, since they wanted you to find the value of alpha, you have to write alpha equal to this. Okay, so be very careful about these. These are easy marks, but you can lose these for these small mistakes. You have to make sure that you don't do that. All right. That was the first part. Now the second part says, state an equation satisfied by alpha and hence find the exact value of alpha. Now the iteration process can never give you exact answers. Exact answers are when you have irrational numbers in the form of pi, square root of something, right? Those are exact answers. Iteration can only give you answers in decimals, which are not exact. Exact answers you can only find when you solve an equation algebraically. For example, if you have an equation like this, x squared minus 5 equal to 0. If you have an equation like this, or maybe x cubed minus 5 equal to 0. The solution of this is x equal to cube root of 5. That's the exact solution of this equation. But iteration can only give you this decimal answer. Iteration will give you 1.709975 to as many decimal places as you want, but it can't give you this exact form. Okay, so iteration is always going to give you a decimal answer. They want us to find an exact answer like this. Okay, now how can we do that? They have given us a hint there. State an equation satisfied by alpha. This is an iterative formula. Which equation does this iterative formula correspond to? How do you find the equation corresponding to this iterative formula? All you have to do is just remove n plus 1 and n from this. What would that be? X equals x into x cubed plus 100 divided by 2 into x cubed plus 25. That's the equation satisfied by alpha. This is the equation that iterative formula corresponds to. All right. Now, how do you find the exact value of x from this? You just solve it algebraically. In case that's possible, let's multiply this on the left side. I'll just simplify this first as it is, x power 4 plus 100x. In the denominator, we have 2x cubed plus 50 equals x. That goes to the other side, becomes 2x raised to power 4 plus 50x equals x power 4 plus 100x. Bring all the terms to the left side, and that leaves you with x power 4 minus 50x equals 0. Take x common, that leaves you with x cubed minus 50 equal to 0. And that gives you either x equal to 0 or x cubed minus 50 equal to 0. X cubed equals 50, and the exact value of x is cube root of 50. Now, alpha is equal to 3.6840. Now, that's clearly not 0, right? So 0 is not possible. This is the only possible answer. We say the exact value of alpha, therefore, is cube root of 50. You can verify this as well by inputting this in your calculator and see if that gives you something close to this or not. Cube root of 50. Yes, that's 3.6840 and so on. That's the exact solution for this equation. That's what they were looking for in the second part. Make sense? Any problem with this? I'll just do one more question and then we end. And then tomorrow, we will just be doing practice questions on this, in addition to sketching graphs of the functions, of course. But we'll spend the whole session on practice questions. I'll just do one more from the worksheet quickly, and then we end for today. Question number 42 from the worksheet. This also tests that other concept that we talked about earlier. Okay, now this is where understanding the statements correctly is very important now, because that's the tricky part about iteration. Sometimes the question statements are very confusing. The working is going to be very straightforward, but you would have trouble understanding what they're asking for in the first place, right? That would be the main problem in such questions. You have this equation x³ minus x² minus 6 equal to 0. And they have given that this has one real root, denoted by alpha. It's a cubic equation. It has one real root. We need to find by calculation the pair of consecutive integers between which alpha lies. Now, what does that mean? Pair of consecutive integers between which alpha lies. Alpha is the solution to this equation, right? Consecutive integers. So what are integers? Any numbers like these: -3, -2, -1, 0, 1, 2, 3, 4, and so on, right? Let's suppose alpha was equal to 7.83. I'm just inputting a random number here. Let's say alpha was this. Which two consecutive integers does this number lie between? It lies between 7 and 8. Right? These are two consecutive integers between which this number alpha lies. That's what they want you to figure out. Which two values of x does this value of alpha lie? Does the solution of this equation lie? Now, how do you figure that out? How do you know that a solution exists between two values? Remember that method that we did in the beginning. If you have an equation that looks like this, x³ minus x minus 6 equal to 0, first of all, you have to convert it to the form f of x equal to 0 by bringing all terms to one side and having only 0 on the other side. Do we have that form here? Yes, we do have that form. This is f of x, and we've got 0 on the other side. And now what you can do is, you can start inputting integers randomly. So since we don't know whether it's going to be positive or negative or whatever, let's start with small numbers first. Let's try f of 0, for instance. What's f of 0? F of 0 is -6. Okay, that's a negative number. Let's try 1. What's f of 1? 1 minus 1 minus 6. That is also -6. That's also a negative number. So sign is not changing yet. Try another number, f of 2. If you input 2 here, that gives you 8 minus 2 minus 6. Is that exact 0? No, this is x². I'm sorry. This is x². Okay, at 0, we get -6. At 1, we get -6. Okay, both of them are correct. But then you have f of 2. What would that be? F of 2 would be 8 minus 4 minus 6, which is -2. This is again negative. Again, the sign is not changing yet. All of these values are negative. Okay, let's try 3. At 3, you would have 27 minus 9 minus 6, which is 12. This value is positive. So now you see, from 2 to 3, from x equal 2 to x equal to 3, there is a sign change. Right? If the sign is changing, it's going from negative to positive. That means 0 is going to be somewhere in the middle, somewhere between them, right? So we can say alpha lies between x equal to 2 and x equal to 3. It has to be between these two values, x equals 2 and x equals 3. These are the two consecutive integers between which alpha lies. Make sense? Yes. So now, what working is necessary for you to show here? What working is necessary for you to show? Do you show this for all of these necessarily? The trick here would be, you just use your calculator, go to the equation function. It's a polynomial. It's a power degree 3 polynomial. Just input those coefficients here. 1, -1. X coefficient is missing, so that should be 0. And then the constant term is, okay, I'm sorry, I missed that. 1 minus 1, and the constant term is -6. See what solution you get from this. You're getting 2.218. That lies between 2 and 3. So you know that, okay, the answer is 2 point something. You can just directly show this working, that f of 2 is -2. And then show f of 3 is 12. Sign is changing. You say that it lies between 2 and 3. So you can just you can skip this working because you know that they're not going to give you the solution. The solution is 2.21. That is between 2 and 3. You know that already. So just show the working for f of 2 and f of 3. And that's it. Since the sign is changing, you say that the solution is between 2 and 3. The other solutions for this, they are complex, you can see, right? So that's the only real solution. This is complex, and then x3 is also complex. The only real solution was that 2.218, and that lies between 2 and 3. Okay, that was the first part. Any problem with this? Any questions, anyone? The first part? No? Now, let's look at the second part. Again, another type of question that gets repeated very often. You need to understand what the statement means. Show that if a sequence of values given by this iterative formula converges, then it converges to alpha. Now, what on earth does that mean? If a sequence of values, what sequence of values? When we use an iterative formula, we get x1, x2, x3, x4. This is the sequence of values that they're talking about. That those iterations that you get from that iterative formula, if that sequence converges, if those iterations converge, that means if they converge to a single answer, if they get stable at some value, then that value at which they get stable, that value is alpha. Now, how do we show that? We don't even know what the value of alpha is. We have only shown that alpha lies between 2 and 3. That's all that we know. And look at this third part. In the third part, they want you to use the iterative formula. That means in the second part, you don't even have to use the iterative formula. You have to do it without that, because the iterative formula actually has to be used in the next part after that. Okay. So how do we approach this now? Let's understand the question statement again. This is the equation that we have. We know that this equation has a root that is alpha, right? The equation has a root that is alpha. And then we have some iterative formula that they've given, and they are asking us to show that this iterative formula should give that same solution alpha. Now, how can we prove that without actually finding the value of alpha? Because we have to do that in the next part, right? So without finding the value of alpha, how can we prove that this iterative formula is also going to have the same solution? We can do that by proving that this iterative formula belongs to that equation. What's the equation? The equation is x³ minus x minus 6 equal to 0, minus x² minus 6 equal to 0. That's the solution. That's the equation that we have. The iterative formula is xn plus 1 equals square root of xn plus 6 over xn. That's the iterative formula. We know that the solution of this equation is alpha. We have to show that this also gives alpha as the solution. How can we prove that? We can prove that by showing that these two things, they correspond to each other. That means that this iterative formula is actually coming from that equation. All right, now you can go in either direction. You can either start from this equation and prove that it can be written in this form, or you can go backwards, convert this iterative formula to this equation. And that would prove that this formula corresponds to that equation. Therefore, the solution that you would get from this would be the solution of that equation. Okay. Now, how do we go from this iterative formula to that original equation? We remove n plus 1 and n. that would give you x equal to square root of x plus 6 over x. Take square on both sides. That gives you x squared equal to x plus 6 over x. We want to get rid of the fraction now. We have x in the denominator. I can multiply the whole equation by x. And that gives me x cubed equals x squared plus 6. Take all terms to one side. X cubed minus x squared minus 6 equal to 0. That means this iterative formula corresponds to that equation. Okay, so since this iterative formula corresponds to that equation, that means it is also going to have the same solution. The solution that we would get from this, it will be alpha. That's what we have to prove, that it converges to alpha. So it has to converge to alpha because it corresponds to that equation. Does this make sense to everyone? Because this is something that, again, keeps getting repeated, the same statement or a similar statement. Okay, that was the second part. Now the third part just requires you to use the iterative formula. I'll just do it one last time today. Tomorrow we will not be doing these parts where we have to use the iterative formula. That's fairly straightforward, right? You can skip these parts tomorrow. We'll do the rest of them for every question. But let's do this one. Use an iterative formula to determine alpha correct to 3 decimal places. Okay, now we have the iterative formula given, that's xn plus 1 equals square root of xn plus 6 over xn. That's the iterative formula. We have to find the value of alpha from this. Now we need a starting point for that. Do we have a starting point? Have they given us any starting point in this question? In the previous question they told us that x1 is equal to 3.5 is the starting point. In this case, they haven't done that. We have proved in the first part that alpha lies between 2 and 3. The starting point is supposed to be our best guess about the actual solution. Now, what's our best guess? We know that the solution is somewhere between 2 and 3. So we say, let's just take the midpoint of 2 and 3. Let's take 2.5. Okay, that's the best guess about the actual solution, 2.5. Okay, and now you just use the calculator to find x2, x3, x4, and so on. Put 2.5. That saves 2.5 in the answer button, and now you put that formula in place of xn. You write answer in your calculator, so it will be square root of answer plus 6 divided by answer. That's all that you have to do now. Press the equal to button. Iterations have to be correct to 5 decimal places. The final answer correct to 3 decimal places. Generally, you would see that there will be a difference of 2 decimal places between the number of iterations that the level of accuracy in the iterations and the level of accuracy in the final answer. There will be a difference of 2 decimal places. Keep that in mind, because you will find a couple of questions in which they will just tell you the level of accuracy for the final answer, but they will not tell you the level of accuracy for iterations. The general rule is iterations are going to be 2 decimal places more accurate than the final answer. Okay, so if they don't tell you that, whatever is the final level of accuracy that they want, add 2 decimal places to that for your iterations. Okay, in this case, they want 5 decimal places. Let's write it to 5 decimal places. 2.21359 x3. Press the equal to button again, and that gives me 2.2190353. So that should be 4. Okay, if you write 3 here, you lose 1 mark. x4, that's 2.21876. x5, 2.218777. That means it's going to be 78, right? x6, 2.21878. That's fairly stable. In fact, all the decimals are stable. We can write down the final answer to 3 decimal places. that is going to be 2.219. That's the final answer. This is supposed to be the value of alpha. So we write alpha equals this. Otherwise, again, we lose 1 mark. Okay. So we have to write alpha equals 2.219. That is the final solution. And that's what we wanted. Is that all right? Any questions on this? Now for tomorrow, I want you to attempt questions from the worksheet. Try to do all of them, all the assigned questions, or at least as many as you can. And along with that, please revise trigonometry graphs from paper 1, right? I'm not going to go through them again. I'll just show you the graphs, but just go through their shapes again, the ones that you did in paper 1. Sine x looks like this, cos x looks like this, and tan looks like this, right? You can use the table function on your calculator to sketch these graphs. I will show you how to do that for the other functions tomorrow. You can do the same thing here as well. You will find this in the trigonometry videos that I shared with you earlier. If you've forgotten how to sketch these graphs, the trigonometry videos that I shared with you earlier for revision, you can have a look at the last video in that playlist on trigonometry, and you would find this explained there, how to sketch these graphs. But this was in paper 1. I expect you to know this. So please revise this for the next class. And then tomorrow, we will be discussing how to sketch the graphs of the 5 remaining functions: cot, cosecant, secant, and e power something or ln of something. And in addition to that, we would be doing a lot of practice questions from the worksheet. Okay. Please try those questions for tomorrow, so that tomorrow we can try to wrap this up. If we need to spend another class on doing some more practice, we could do that as well. Ibrahim, sona nahi aapne? Differential equations questions. Okay, let's do them. So we end this class here. For everyone who wants to leave, Ibrahim has some differential equation questions. I'll answer them in the next 5 to 10 minutes, hopefully, and then we end after that. All right. So those of you who want to leave, you're free to leave. I've taken quite some extra time from you already. You're free to leave now. I'll see you again tomorrow. Please make sure to attempt practice questions from the worksheet. I'll just answer Ibrahim's questions quickly in the next 5-10 minutes. Yes, Ibrahim. Let's be quick.
So I'll send you the working on WhatsApp. That's question number 17, part 2.
Okay. Let me share this here. G, what about this?
तो इसका जो n वाला पार्ट है जो एंड में है जहाँ पे रेड हुआ हुआ
Is this notability, by the way? It looks good.
No sir, it's note n.
Note?
Note n.
Note n. Sure.
Android पे sorry.
Say Android पे. Looks like a good interface. इसको रियल टाइम में शेयर कर सकते हैं? वन नोट में रियल टाइम अपडेट हो जाता है कि मैं लिंक शेयर करता हूँ इससे, तो अब वो नोट्स अपडेट होते रहते हैं. ये भी इस तरह से होता है रियल टाइम में? नहीं, वो पीडीएफ ही शेयर करना पड़ता है.
जैसे वन नोट का होता है ना उस तरह में.
मतलब रियल टाइम में अपडेट नहीं होता कि किसके साथ लिंक शेयर करें.
आप पीडीएफ शेयर कर सकते हो आप PDF शेयर कर सकते हो, लेकिन वो नहीं होता, रियल टाइम में अपडेट नहीं होगा।
ठीक है, दैट्स द प्रॉब्लम आई हैव विद नोटेबिलिटी एज वेल। PDF शेयर करने पड़ते हैं, वो फिर बहुत लंबा काम हो जाता है। अच्छा जी बताएं।
सर इसका जो लास्ट पार्ट है, इसके अंदर मैंने n के निकाल लिए वैल्यू, वो सही है, n की वैल्यू जो भी है, जो मैंने t में निकाला है, उसके अंदर सर अब वो कह रहे हैं कि जब बहुत ज़्यादा हो जाएंगे आफ्टर अ लॉन्ग टाइम, d जब इन्फिनिटी पे चला जाएगा, तो वो कैसे सॉल्व करना है इसके अंदर, ये नहीं समझ आ रहा।
Okay, the easy way of doing this is just put this on a calculator. Okay, so I'll explain to you the logic as well if you want to do it that way. But आसान तरीका ये है कि आप calculator में डाल दें इसको. But if you were to do it directly, the way to approach this would be, how do I annotate this? Okay, so this is how you can think of it without a calculator. Think of what happens as t becomes very large. Numerator में क्या होएगा? 1800 e raised to power infinity over 2. That's like e raised to power infinity, right?
हाँ जी,
Denominator में क्या होगा? Let me actually write it exactly like that. Infinity over 2. Denominator में क्या होगा? 5 plus e raised to power infinity over 2. Right?
हाँ जी,
अब देखें, e raised to power infinity over 2, that's an extremely large number, right? That's extremely large, e raised to power infinity over 2. Now, in the numerator, that's getting multiplied by 1800. Denominator में आपके पास e raised to power infinity over 2 है. Again, that's an extremely large number. But then you have 5 added to that. Okay. अब वैसे अगर आप सोचें कि अच्छा न्यूमरेटर भी बहुत बड़ा हो गया, सो दैट्स इन्फिनिटी, डिनोमिनेटर भी बहुत बड़ा हो गया, वो भी इन्फिनिटी है, सो दैट माइट नॉट मेक सेंस टू यू। अच्छा इन्फिनिटी और इन्फिनिटी, व्हाट वुड दैट बिकम? बट थोड़ा सा सोचना पड़ेगा इसमें अगर आप डायरेक्टली करना चाहते हैं. If you have an extremely large number and you add 5 to that, does that make any difference? अगर
नो,
उसमें 5 ऐड कर दो, कोई फर्क पड़ेगा उसमें?
नोप।
So we can say that this is almost the same thing as 1800 e raised to power infinity over 2 divided by e raised to power infinity over 2. That 5 is kind of insignificant. उसको आप ignore कर सकते हो.
हम्म,
And that leaves you with just 1800. That's the value that you would get in this case. ठीक है? If that's hard to think of, you can just put this on a calculator
ओके,
and do something like this. 1800 into, calculator में कैसे input करेंगे? कभी कभी आपको math error दे देता है. So you have to be sure how to use this. E raised to power infinity over 2. Infinity की जगह पे put a large number. So we generally put 10 raised to power 10, but it's most likely going to give you an error because power में जब 10 raised to power 10 आ जाएगा तो वो calculator handle नहीं कर सकेगा. Let's do this is your 10 for now. ठीक है, 10 करते हैं, फिर थोड़ा सा चेंज करके देखेंगे उससे फर्क पड़ता है कि नहीं. तो लेट्स से हमारे लिए लार्ज नंबर 10 है, पावर में आ रहे हैं, ये 100 कर लेते हैं. चलो 100 कर लेते हैं और डिवाइडेड बाय 2. ठीक है, हमने बड़ा नंबर डाल दिया टी की जगह पे. डिनोमिनेटर में आ गया 5 प्लस ई रेज टू पावर 100 over 2, 1800. That's what you wanted.
ओके,
ठीक है.
ठीक है सर, समझ गया।
नेक्स्ट. बस
नहीं सर, एक और भेजेगा आपको।
अच्छा जी, इसमें क्या है?
तो इसमें बस वर्किंग चेक कर लें एक बार, और ये थर्ड पार्ट ये भी नहीं समझ आया था।
Okay, is the answer not correct for the second part?
Yes, it is 4/3e minus 4 6 plus 1। मैंने लिखा हुआ साथ था।
Okay, so the only problem that you have is the sign, negative sign. बाकी equivalent है. The only problem is the negative sign that you have there. Okay, let me paste this here. First part चाहिए, partial fractions आपने सही निकाले?
हाँ जी सर, वो सही है।
So 1/4. These also 1/4. 1/16 minus 4y. Okay, ये आपने सही किया वैसे तो, but just a suggestion, इसको इंटीग्रेट करने का सिंपलर तरीका यह होता कि बस आप 4 को बाहर लिख देते हैं. So इसको लिख देते हैं 1/4 integration of 1/y, and that will just become 1/4 L and y. But that will be simpler. This is also correct जो आपने किया. This is equivalent, but this would make it simpler, right?
हाँ जी सर, समझ गया।
अच्छा, 16 minus 4y. अच्छा, minus 4 चाहिए तो प्लीज ऑलवेज यूज ब्रैकेट्स. मैंने आपको लास्ट टाइम बताया था, ये ब्रैकेट से बगैर नहीं लगना आपने. Ellen is applying with this whole thing, right?
Yes, yes sir.
We have to use brackets like this.
Okay.
So then you take 1/4 common outside. That leaves you with 4/16 minus 4y. ठीक है, यहाँ तक सही है. y1 x0. This is e raised to power minus 4xy, right? Sorry,
Yes sir.
minus e raised to power 4x times y. जब ये लेफ्ट साइड पे जाएगा तो प्लस हो जाएगा ना.
ओ हाँ, हाँ जी सर।
तो ये प्लस होना चाहिए, ये प्लस होना चाहिए, और ये प्लस होना चाहिए. And then it's correct. These two are equivalent. ये दोनों सेम है.
Okay.
अगर आप
सर लेकिन ये कैसे सेम कैसे होंगे, वो स्लिट ही नहीं होगी जो फ्रैक्शन है?
इसको e⁴x से मल्टीप्लाई डिवाइड कर दो, you get 4e⁴x divided by 3 plus e⁴x. That's exactly what you have there.
ऑलराइट सर।
ठीक है, तो आपने जो किया है that's also acceptable, that's correct.
ओके सर। और जो थर्ड पार्ट है जो वेरी लार्ज एंड पॉजिटिव हो रहा है, तो वो हम पॉजिटिव इन्फिनिटी के लिहाज से देखेंगे और लाइक बड़ी वैल्यू डाल के मैं निकाल लूंगा आंसर।
तो अगर आप वो खुद से सोचना चाहते हो तो वही आइडिया जब मैं वहां पे यूज किया था, e⁴x is a large number,
हाँ जी।
इसमें 3 ऐड करें ना करें उससे कोई फर्क पड़ता?
नहीं पड़ता।
तो 3 को आप एलिमिनेट कर दो वहां से, तो
ठीक है।
4e⁴x डिवाइडेड बाय माइनस e⁴x, ये कैंसिल हो जाएंगे, -4 आपके पास बच जाएगा।
ठीक है सर। ओके।
या फिर कैलकुलेटर में बड़ी वैल्यू डाल दो।
ठीक है सर।
ठीक है,
ओके सर, थैंक यू सो मच सर।
अल्लाह हाफिज़।
बस।